Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, I will help you get started with worksheet for Class 2, Introduction to R and RStudio. So we'll go down to the timetable, find today's date, and we'll look over for the worksheet. So we've got Class 2. By this time, you've reviewed the chapter and the 2 videos that accompany the chapter, and we're going to be working on this worksheet here. I'm going to open the Intro to R in a new tab. You can hold Control and click, or you can do a right click and open a new tab. We're going to be downloading this QMD file, so let's save that link as into your ADA folder, wherever that is on your computer. And I'm also going to open that QMD file, the Quarto file, here, just so you can see what the output should look like. So after we compile it, it's going to look like that. Let's go over to RStudio. Okay. And let's see. So we'll open that file. You may need to navigate to find that file. Here it is. And every time after you open a QMD file, go to Session, Set Working Directory to Source File Location. That means that wherever this file lives, that's where it's going to expect to read and write input and output. So that will submit a command down to the console for that folder, and it should also appear in the line just above the console. All right. Where to get started? Okay, so every time you download a file, set the working directory and render it. That will assure that it's working from the beginning, and that any errors that the file has is something that you introduced and didn't come with the file. You basically, that's not the point. The point is that you want to start with a file that's working, and then if you do get an error, you can hunt down that error. When you render it, it probably pops up in your browser or in a preview window. On mine, I've got that turned off, so I have to go over to the file folder and open that file manually. All right, so here it is. We'll work on the one that's on the computer and not on the website. Recall from the introductory lesson that this top portion of the QMD file between the triple dash and the triple dash is called the YAML. That's yet another markup language, the YAML. It's a way of specifying the properties of the document, such as the title, the author, the date, a description, and then what the output format is. In this case, it's an HTML with a certain set of options. Okay, and we'll just leave all that as it is. If you want to put your name in here, you may. It won't affect how it's graded. Then we've got a header, the rubric, and I've got a couple of hyperlinks in here, and we'll just go over to the website and take a look at it there. So it generates, right, that the header information with your title and description and author and date, a table of contents, and in this case we've got 7 questions to answer, and the number of points for each question is listed over here. They should add up to 10. If they don't, I've made a mistake. And here is the intro of the assignment. The context of this assignment comes from these open intro labs, and the first one is this intro to R. That is the same as this page here that we're going to look at. But if we did open that in a new page, you'll see that it links there. Okay. Oops. All right. So the first thing that, I do say that this is a template for the assignment. I expect you to open it, modify it, render it, print it to PDF, and turn it in to Canvas. All right. This assignment requires 2 libraries to be loaded, the tidyverse and open intro. The tidyverse gives us a set of functions for data manipulation and visualization, and the Open Intro package provides us with some data sets. In this case, we'll be using 2 different data sets. Those data sets are listed here, the Arbuthnot and the present. And they're basically 2 data sets that are similar to each other, having to do with number of girls and boys who are born at 2 periods of time. All right, so let's go over to the Open Intro Lab website. And my goal for these early assignments are to give you a lot of detail and let you practice a lot. And I'm going to give you a lot of the answers in these videos, but I hope that you're going to follow along and do the things I ask you to do. Get comfortable with submitting commands to R, seeing what the output is. If you get an error, being able to track down, where you've missed closing a parenthesis or missed a comma or spelt something wrong, interpreting some error messages. I'll probably try to even introduce error messages purposefully so you can see some of the things that can happen, and then learn to read the error message to give you a suggestion as to where the problem might be. So these videos, especially these beginning videos, are going to be a little bit longer because I'm going to give them a lot of detail. Okay? All right, so the goal of this lab is to introduce you to R and R Studio, and you'll use this throughout the course and hopefully later in your career as well. R is the programming language, and R Studio is a wrapper that makes it easy to work with R. All right, I'm not going to read all this stuff. We've done a little bit of R already in the first worksheet. All right, we know about some of these things. Okay, we've already installed these 2 packages, the tidyverse and the Open Intro package. We need to load those. I've explained why already. And you can find more about these packages in the tidyverse at tidyverse.org. I do recommend that you go here. If you go to the tidyverse.org and take a look at the packages, I will point out that you probably want to just read through what the core tidyverse is. In particular, ggplot2 is a way of creating plots using the grammar of graphics. And I'm going to help teach you a lot about that. dplyr, the main part of plyr is the ply. That's short for apply. So the basic idea of dplyr is that you take a data set, you might split it into pieces, apply some function to different parts of it, and then combine all those results at the end, and then do another step similar to that over and over again to manipulate your data. It has become a very powerful grammar in the last 8 or 10 years using R. tidyr helps you sort of format data a bit, and then there are some more specialized packages later on. But those are I would say those top 2 in particular are the most important. All right. There are 2 videos on this page. The first is about using R Markdown to create lab reports or any report, where you take blocks of code and paragraphs of text and you weave them together. So you've got, as this picture shows, some code that does some data analysis and then some description about what the results are and interpreting those results. Then you might have some text that says, next I'm going to do these analyses, or we're going to use this particular method. Then you write the code that does the method, produces the plots and the tables and other summaries, and then you write some more text to interpret what you have. And that is the approach that we're going to be using. So you can watch this video if you like. That's the basis of it. The second video about lab reports we can ignore, in particular because I'm going to be providing you the template for the assignments. All right. We're going to learn about those things. All right. So let's get into the work now that we're 10 minutes into the video. All right, so our Booth-Knott's baptism records, this is a way of measuring births, okay? In a time when everyone was baptized, I guess this is a way of counting the babies, okay? So let's go over to RStudio. We're going to bounce back and forth between RStudio and this assignment. All right, so here I am in RStudio, and now I'm going to tell you a bit more about RStudio because this is the first time that we have these code chunks, okay? Let me show you a couple things. So first of all, this is a text editor. You can type in here and move things around, okay? It's similar to a word processor like Microsoft Word, okay? If you start and end some text with 3 left inverted commas, right, apostrophes, that's in the top left corner of your keyboard under your escape key. Do 3 of those to begin and 3 of those to end. If I render this, let me do, well, okay. It's ugly, but I'm not going to use a lot of time actually typing words, okay? So let's go look at the result of that. I have to refresh my page. If I do that, it gives us fixed format or fixed width text. Whatever I put in there, that's exactly how it appears, okay? So that's the first part about using these ticks. Now, if I want to interpret what is in those ticks with a particular programming language, I use a pair of curly braces and I specify the language. If I want to use R, I put R in there. If I want to use Python, I put Python in there. If I want some other language, I put that other language in there. And provided that it's on the computer and it plays well with RStudio, it will run. Now, this is not valid R code, so if you try to compile this or interpret it, it will get an error. So I'm going to delete that right now. But that is sort of what we're doing. This, and in RStudio, it provides this gray line or gray background color to indicate that this is code. Sorry. So let me delete the junk I just put in there. There's a few ways of submitting these lines to run. We will often use the Control-Enter input. So let's see if there's a, oh yeah, we can go to Help, Keyboard Shortcuts, okay, Alt-Shift-K. So I recommend you learn all of these. No, just kidding. I recommend that you read through some of these. In particular, oh, I wish they sort of had, wish they had like, oh, see all shortcuts. This isn't all of them? Okay, I clicked on all shortcuts. You know, I don't know all of these, but I do know some. So you can jump between windows with Control and a certain number. Let's see. So for example, Control 1 will jump up to the editor window. If I press Control 2, it will jump down to the console window. Control 3, Control 4, Control 5. They're going to these different tabs. I don't know what the different numbers are, but you can see it's sort of a way of choosing which window that you're in. I basically use Control 1 and Control 2 to help me move between these two windows without having to move over to my mouse. Okay. Okay. There are lots of things, lots of possible keys in here. The main one we're going to use, which I'm not finding right away, Control plus Enter. Wow, it's buried in the middle. Run current line or selection. That's the main one that you're going to use. So if you're on a line and I press Control Enter, that's equivalent to copying the line, pasting it into the console, and pressing Enter to submit that line. Okay, so on this time, I'm going to just put the cursor on that line for library intro. I'm not going to highlight the line, but you can, but you don't have to. I'm going to press Control Enter. It moved it down into the console. It ran it. it loaded some other packages. Okay, so other ways of running the code is in the top right corner of a code chunk, we have a little play button, this little green triangle. If you press that, it says run current chunk. So let me clear my console. If I go there and I press play, it copies and pastes the entire chunk into the console and runs them. Okay. Later on, when we've got bigger programs, there's this down arrow with the green line. It says run all chunks above. So if there was a bunch of code that we needed to run first, and then we wanted to work on this chunk, we would run all the code from the beginning so that we precondition our environment to have all the variables and data sets and functions and so on in the environment that we need at this next step. So first we run everything up to there, and then we can run the current chunk, knowing that, you know, the machine is ready for this chunk. I think up here somewhere there's some way of running stuff, maybe code. Insert, no, oh, here it is. It's this menu over here. It's this run menu. So you can run the current chunk, you can run the next chunk, all chunks above, all chunks below, which I've never ever done. You can run all, okay? Sometimes I do that, okay? We can do that. We don't have stuff in our, we don't have code in our chunks right now, so there's nothing to run. But it did do a couple things down there. All right, so that's code chunks. If at some point you end up in where you don't have these play buttons, it's because you have an extra triple tick usually. So let me put in an extra triple tick by accident, right? This poor triple tick's just hanging out all by itself. It's lost. It's sad. Now you can tell, you know, above here, everything that follows the pound sign has this blue text. Below, things look gray. Okay. These play buttons usually go away. I think that there's, oh, if I save the document, does it update it? Oh, this bottom one is missing it. This one has it. This one's missing it. This one has it. Strange. So if you end up with issues where you're missing the play button, it's usually that you're missing, that you've got a code chunk that is either started but not ended, or vice versa. So we'll just delete that. Save it, and we'll get our play buttons back. Okay, so those are just some of the things that can go wrong. Let's get into the assignment. Like I told you, this is going to be detailed. All right, so to get started, let's take a peek at this data. So I think, do we have that over here? All right, so first of all, let's look at the data. I'm going to clear my console. Control L clears the console. There's also a little broom up here that will clear the console. I like clearing the console occasionally, especially if I'm going to print something that I need to look at, because I will definitely know where the beginning of it is if the console is clear. So I'm going to go onto that data set line. I'm going to press Control Enter, and it's going to print the first 10 lines of data into the console. This data set has 3 variables, year, boys, and girls. It's the year starting in the 1600s, okay, the number of boys and the number of girls. And this is telling me that there are 82 rows, and after these first 10, there's 72 more of them, okay. It also is giving us some other information down here. Use print n equals some number to see more rows. So if we wanted to see everything, we could pipe the data set to print. And how many rows do I want? Infinity, right? That's a way of specifying all of them. So if I do that, I will get from the first down to the 82nd last row that ends in 1710. Okay. Let's go back to here. All right. So we can run by pressing Control Enter, Command Enter on a Mac. Okay. The run button. Okay. The green arrow. We've talked about those things. All right. We've got 82 observations and 3 variables. All right. We're measuring. This is children born in London. Okay, let's see what else here that's important. Oh yeah, the environment tab. So there are lots of tabs, right? So we've got two windows on the left, our editor and our console. On the right, we have two windows, but a bunch of tabs. I often have mine open to the help because I'm looking for help on functions all the time. In fact, we just had this data set, right? We can look at the data set. We can ask for help on the data set. So the question mark asks for help, and then whatever follows the question mark is what we're asking for help on. The top of the help window has the package that the object is from. This is a data set. It could be a function. Those are the two main things that are in packages. This is the object name. It's a data set. Right? This is a description, the title of it, the description, how it's used. You use it just by printing it. It's a TBL, that's a Tibble data frame with etc. It's got these variables and it's got a description. Okay, in this case, it's got where the source came, where the data came from, and some examples. One nice thing about the new version of RStudio is that you can click Run Examples, and all the examples down here will run in this help window. We used to have to, excuse me, I was going to sneeze. We used to have to copy these examples over to the console and run them. But right now, I just click Run Examples, and it shows some code, and then the result of that code. Okay, and we can use these arrows to go back to where we came from. At the bottom of a help entry, you can click on Index and see all of the functions or data sets that are in a package. In this case, the Open Intro has a bunch of data sets primarily. So sometimes I just go to a package, I go to the index, and then I search for the thing that I need in there. Okay. Environment. Okay, we're looking at the environment. So we're looking at these tabs. Environment tells you what objects you have in your memory that you can work on. So this Arbuthnot is a data set that we can access, but it's not in our environment yet. But we can still use it. If we want to put it into the environment, we say data of that, and now it's in the environment. If we make any modifications to the data set, it'll modify it and it'll be in our environment. Okay. Oh, you know, a lot of folks like to I think click on this somehow. I never do this, but oh yeah, if you click on this little table, it'll just print the object up here. You get a new tab, and you can inspect an object. Okay, and you can click on these things, and you can sort it by different columns, ascending or descending. So it's sort of a quick way of looking at a data set. I always write code for it instead, but I can see its use for. So you know, I go ahead and look at it that way if you want. To look at the dimensions of a data set, there's lots of ways. This suggests this glimpse function. We can try that. So we've got this data. When you print the data, it actually tells you what it is. Okay, but we can also pass this to glimpse and run that. I press Control Enter, and it submitted the line down here. It tells us that it's got 82 rows and 3 columns. The dollar signs indicate the column names. It has a more general meaning also in R, that it's a sublist, but that's not really important for us. These are the column names. These are the types of data it is. These are integers, and this is the list of the first so many, whatever fits on a line, observations for each of those. I actually prefer str, which is structure. Gives you a lot of the same information. It tells you the rows and columns. It also tells you that this is a Tibble data frame, but it also has other class types, including a data frame. Some functions work with data frames and not with Tibbles. Tibbles is a modern version of the data frame. A data frame is just a table where each column can have a different data type. One column could have integers, one can have characters, like words and things, one could have dates. So each column can be formatted differently. Unlike a matrix, where a matrix, all the values need to be numbers. Okay. Okay. All right, very good. So ways of specifying, there's ways of looking at the data one column at a time. So we know that we've got these three variables, year, boys, and girls. And recall in both of these glimpse or structure, we had these dollar signs before each variable. So if we wanted to print out just the boys column, we can just have the data set $boys, and it prints the values associated with that column. Okay. Spaces don't matter. It works whether there's spaces there or not. You will rarely see spaces there, but just so you know. Yeah, there are other ways also of specifying column names, which I won't show you at the moment. All right, so this assignment has 7 exercises, I think. The first is, what command would you use to extract just the counts of the girls? Okay, try it out in the console. Well, we just did it for boys. We can do it for girls as well. So those are the frequencies for each of the years for girls. These leading numbers in brackets are an index number. What position is the next value in our list? Okay, so number 1, this number 4683 is in the first position in this list. Then you go across this long list, and it would be hard to look at that and realize that that's 17 wide, but I know it is because the next value on the second row is in the 18th position. So 3395 is the 18th value in this list. And on this last row, 7767 is in the 69th position. Okay. Okay, that's good for now. Okay, very good. All right. Now we're going to make a plot. So I'm going to copy this code. All right. Trend for girls is, so the question is okay. Let's review the code over here first. It says, R has some powerful functions for making graphics. We can create a simple plot of the number of girls baptized per year with the following code. So here we start to get into ggplot. You've seen a bunch of this ggplot in the video, probably the second video, I think, for this chapter. ggplot is a way of assigning visual attributes or encoding visual attributes to columns of data. Okay, in this case, we first specify what the data set is, and then we perform the encoding. The encoding in this case is wrapped with AES, which is short for aesthetics. I guess AS for short, unfortunately, or ACE. But the aesthetic so then we start mapping things to the X variable, which is the x-axis. We're going to assign the variable year. To the y-axis, we're going to assign the variable girls. And then at that stage, we haven't actually created a plot yet. Okay, let me go show you that in RStudio. So we've got the girls. If we just run that, it creates a plot. Isn't it great? We've got year and we've got girls. But there's nothing plotted because we haven't told it what geometric object we're going to use in the plot. I'm going to show you how I do plots. I'm going to assign this ggplot to this object called P for plot. And then by and then by having P all by itself, it prints the plot. Okay. In the plot window, if you click on the broom, you can sweep the broom. You can get rid of all the plots. Okay. All right. There's another reason why I do this. You will all see almost everyone else. Once you create a plot, then you add to it a geometric object, or you add some other formatting to the plot and so on. I make that a little bit more explicit because those dangling plus signs are hard for me to find sometimes, and I think this makes it a little easier, and you can more easily comment out different aesthetics. So let's play with this for a little bit. Geom point. Geom is the geometric object, and what geometric object? It's a point. So after we've assigned our axes, we want to then display the values with points. To that, we can also add a line. So a geom line will connect the dots. I believe it connects the dots in the order it appears in the data set. So if the years were not sorted, ascending, okay, so there's the top of the data set, right? These years are in ascending order, so it's connecting the dots in that order. I think if you were to sort, randomly, or say sort by boys from fewest to most, the dots would be connected in a different order. All right. Okay, so we've sort of like gone beyond what we're. Okay, anyway, so there's some things. Okay. Okay, in this code we use ggplot, aesthetics, plus. Okay, they can also do a line. Okay, so they did that as well. So here's our question: is there an apparent trend in the number of girls baptized over the years? Well, let's see. They just plotted girls, and we're looking at girls. Okay, how would you describe it? So there's really no code to write for this, except maybe just copying their code, which we sort of have done here. So I want you to write the text of your answer here. So we can delete that. Is there an apparent trend in the number of girls baptized? Okay, well, first of all, it's increasing, but had a big dip between, say, 1640 and 1660, roughly. That's the general trend. There's definitely sort of an outlier here, but otherwise, like if you were to draw a line on this top group, you can see it's almost a straight line, except for this strange situation here. I don't know enough about English history to know what happened here. This could be 20 years of famine or a war or something like that. Okay, so definitely write something like that. Okay. And how much is it increasing? So you might even go on to figure out roughly how much that is. So from, say, 1650, which is here, to 1700, which is up here, we go 50 years and we increase about 200. So 200 by 50 is 40. So I guess we're getting about a slope of about 40 per year. Okay. You can do a better job than I just did estimating that. Okay, but there's some, so we've got an answer and we have the plot to back it up. Let's render this. I recommend rendering it often so that if something stops working and you get an error, it's probably the last thing that you did. Okay, so we'll go over here. I'm going to refresh my web page. You can click on the spiral, or you can press F5 or Control R, and we've got the data set here that's printing our glimpse and structure. I have a bit too much output here because I'm sort of teaching as I go. I recommend just having the stuff that you need. what command would you use to just extract the girls? I'm just going to extract the girls. In fact, I'll put the structure there and then I'll extract the girls. And then we've got, so my output will just be the girls. Number 2, the trend of the girls. We've got our code for that trend here, and we've got the text that we just wrote. Had a big dip between those years and a slope of about 40. This might be wrong. Correct me. You don't even need to put this in. I was trying to add a little more context. Okay, let's go over to here. All right, you might wonder how you're supposed to know the syntax. Oh yeah, good question. So we can go to that tidyverse page, or any function that's in here you can ask for help on. So we can do !ggplot. In the help window, we've got some notes here about first the data, then the mapping, which is the aesthetics. Now, we probably should say, here we could do like mapping equals. In R, when you have a function with different arguments, as long as you specify them in the same positions, the first, the second, the third, you don't need to specify what is being mapped. So anyway, you don't really need that. Okay. Same thing here with geom_point. You can search for help for that. Geom_point, it has some things you can put in here, and there's a lot of options hidden inside this triple dot, the ellipses. So the mapping, okay, I'm getting too deep into some of these details. I'm gonna stop and then stop with the help and continue. But you can learn some things here. Often the more effective way is, if you want to do something specific, is to search for R, ggplot, points, maybe something about like color and transparency. Okay, and if you spell it right, you will get some web pages with examples about how to do things with different colors and levels of transparency. Do we have any transparency? Here we go. Alpha is our transparency, where the dots are transparent. Googling, you'll find tons of answers. All right. Okay, we've already seen R as a calculator where you can add things together. We're going to create a new variable that has the total, and we're going to use that ultimately to get the proportion of boys or the proportion of girls or something. So here's the proportion of boys to girl ratio. Okay, so we're going to go over and do these things because our goal is to generate a plot of the proportion of boys born over time. Okay, so we want to know, like, are there boys to girls? Are there more? Is that ratio changing? We don't really want the ratio between boys and girls. We want the ratio, yeah, this way, boys over the total. So the proportion of boys. Okay, okay, the proportion of boys. So we need to write some code for the proportion of boys. So the first, we can start with the code that they wrote. I think that's probably a good place to start. Let's do this one here. All right. I'm going to change this around a little bit to make it a little easier to read. Okay. And so there's two versions of this pipe. Does this web page describe how the pipe works? I think it does. Here we go. So piping is sort of a new concept in R, but it's been around in Unix and later Linux and MS-DOS for decades. The concept of a pipe is to have some output that goes forward as input to the next operation. And then that produces some output, and that output is then piped as input to the next operation. So you can chain operations together. Okay? And the way that happens in R is if you've got this function f, say f of x, y, where f can takes a first argument x and a second argument y, and then it's going to use those two arguments in the function to do something, add them together, whatever. So the way what piping does is it takes the output from the previous operation and puts that in as the first argument into the function. So x piped into f of y is equivalent to f of x comma y, where the first argument is filled from the pipe, and then the second argument is whatever it is. Okay, this takes a little while to get comfortable with looking at, but how it works is really wonderful. So the second thing I think I'm going to say that afterwards. So we're going to start with the data set, and then we're going to pipe the data set into the mutate function. Mutate, right, creates new variables or modifies variables within a data set. And so mutate needs some data to work on. Where did the data come from? It came from being piped in. Okay, so we're going to pipe the data set into mutate, and then mutate is going to do something. What is it going to do? It's going to create this variable boy ratio as a function of the columns of the data set. So the data set has a column boys, and it doesn't have a column total. So we need to calculate total as well. We can do that here. I think they do that in this somewhere. Oh yeah, they do it here. Right, they've got another example. So we can copy that line, or we could just type it. So we're going to create this line total, which is the boys plus the girls. So first we create total. Once you create an object in the data set like total, you can then use it in a subsequent line. So now we're going to calculate the ratio, boys divided by total. So let's run this. Oh, and then the last part, after all this is done, the result finally is assigned back to the original data set. So we're going to overwrite the original data set. So if we screw something up, the whole data set might go away. But so I'm going to run that. I highlighted it. I pressed Control Enter. It submitted it down here. Let's take a look at what's there. Cool. We've got the original 3 columns, but now we also have a total, which is the sum of boys and girls, and then we have the boy ratio, which is boys divided by the total. And then what is the question? Now generate a plot of the proportion of boys born over time. All right, we can do that. Let's start. I rarely write code from scratch. I usually copy something and modify it. In my long career, I have lots of examples that I can copy from. So x equals year, that seems about right. But on the y-axis, instead of girls, I now want this boy ratio. So let's put that there. And we can plot the same points and lines. That seems fine to me. Okay, so we plot that, and this is what it looks like. It's centered around 0.52, and there are ups and downs, right? There's variability year to year, but we don't see a strong trend. I can show you there are some methods of putting smoothers, like a regression line or something. So there's something called geom smooth. Let's plot it with that. So I'm going to highlight everything again and run all of it. See, this first line creates P from scratch, and then every line after that starts with P and then adds something to it. And the thing I like about having P plus, P plus, P plus is that you can see the grammar of graphics. It's layered. You start with the data set and the axis. So let me just run this first line and press P. I've got just the axis. Then I add the points to it, and then P, I got the points. oops, sorry. And then I add the lines to it. Okay, and I print that, and it adds the lines. And then I'm going to add a smoother to it, and I'm going to print the smoother. Okay, now this smoother has some curves, right? It's trying to follow the pattern of the data. Within smooth, there's other methods that you can use. In particular, LM is for a linear model. It will fit, the default is to just fit a straight line. So that's a straight line fit to that data. Okay. Now that's well beyond what is required for this question, but there's some detail. Okay. What's the question? Generate a plot. What do you see? Okay. What do we see? We see that it's roughly the same over time at I don't know, roughly 0.52. Okay, that's my answer. All right, I've done some work. Let me render it. Make sure that things are still working. Oh, sorry. I'm trying to, really? Trying to pause my Dropbox because that sometimes creates rendering issues. Let's go look at the output. Okay, here's the question 3, roughly the same over time at 0.52, and there's the plot that we just made. Cool. All right, all right, you guys, oh, it's 46 minutes? You guys hanging in there? You can pause and come back at any time. All right, we talked about piping, about new variables. All right, so then down at the end, we've got 4 more questions, and that's the end. Oh yeah, the other thing I wanted to say is that there's this old version of the pipe, percent greater than percent. There's a newer version, which is native to R, which is just the vertical line pipe and the greater than. You will see both all over the internet. In fact, you will see the 1% greater than percent more often because we've had that for 6 or 8 years. And this native pipe, it's native to R. It doesn't require the Magritte R package, is newer. And so you're not going to see that as often. But you will start to see more and more people use it. So I'm going to start using that. All right, let's zip through the rest of this. So we're now using a different data set, more practice. In the previous pages, we did some stuff, and now we've got some data sets, birth data for the United States. And present just means like from the present times. Okay, we're going to look at these birth data. And all right, and I guess we're going to look at this summarize function, which takes a full set of data and from that produces a single summary row. And you decide what calculations you want to make from that data set. So let's take a quick peek at this function in R. I'm just going to submit it to the console. Okay, so we started with the data set. We piped it into summarize. And in summarize, what did we do? We calculated a minimum of the boys column, and we assigned that to a variable called min. And then we calculated the maximum value for boys, and we assigned that to a value max. And then we didn't assign it anywhere, we just printed it to the screen. And so out of summarize comes a single row, actually the rows down here, with the min and the max columns, the ones that we named, and then the values here. So the minimum value of births in that data set was 2890, and the max was 8426. Okay. So answer the following questions with the present data frame. So first of all, let's see what present is. Okay, so I just typed it, I pressed Control Enter, it submitted down here, and look at these frequencies now. Now we've got 1 million boys and 1 million girls every year starting in 1940, World War II years. And when does when does this end? So there's two functions. There's a function called head, which prints the first 6 rows, and then there's tail, which prints the last 6 rows. So this goes up to the year 2002. It's 2023 right now. Probably some of you were born right around then. Okay, so what years are included in this data set? What are the dimensions of the data? What are the variable column names? So that's all straightforward. How do we get that information? We can look at the structure of the data set. All right, that tells you how many rows and columns and what the column names are. You can also do what they're doing in the on that web page. You can glimpse it. You can look at the dimension of the data set. Oops. So if I press Control Enter on there, we have 63 rows and 3 columns. We can ask for, I'm just sort of like making copies and changing the function name. We can look at the names or the column names. Those, in this case, do the same thing. They are the names. They're the column names of the data frame or tibble. All right, that's all getting at names and the size. What else? We want to know, oh, you know what? I'm in the wrong code chunk. I'm going to move up to number 4. Okay, the years. We want to know what the years are. So how do we get to the years column? Well, we've got present is the data set, $, and R will try to autocomplete for you. Here, once I type $, it's listing the variables in the data set. If I start typing a letter, it reduces the list to variables that have that letter in it. So boys has a Y in it, so it's also listed. If I do YE, year is the only variable that has YE in it. And then if you press tab or click on it, but I'm going to press tab, it will autocomplete what's there. All right, if I press Control Enter there, it prints all of the years. So that's good. It gives us the whole range. So how do we know if we haven't skipped any years? Okay, this is going to be a little bit advanced now. So that's a list of all the years. Let's do some things to this. We can look at the range of the data, okay, and that gives you the minimum value and the maximum value, and help on the range, question mark range, over here returns a vector containing the minimum and maximum. Okay. Let's see. We can look at something called diff. So the difference between subsequent values. So the difference from 1940 to 1941, that's a difference of 1. And it's positive because it takes the next value and subtracts the current value. So 1941 minus 1940 is positive 1. So another way to think of it is when you go from 1940 to 1941, you need to increase 1 unit. Okay? And all of these are 1s. If you had tons of these, it would be difficult to tell that it was all 1s. And so we could, from the difference, make a table of all those differences. And number 1 has 62 instances, and there's no 2s or 3s. So we know it doesn't skip any years. Okay, that's called doing your due diligence on a variable. We know that it has every year from 1940 to 2002. All right, so now that we know that, we don't really need all of this additional stuff. Pound signs creates a comment. So anything that follows a pound sign is not going to be interpreted by R. So it's enough for us to really just put in the year or the range. Okay, remember that row gave us the first and the last value, or the minimum, not the first and last, but the minimum and the maximum value. Okay, so we've done some work. Let's render our work. Make sure that it still runs all the way through. I haven't produced a lot of errors yet. but I'm going to refresh the output. Okay, data properties. And so here you would write your answers to here. I'm going to skip over writing the answers, but we know what years are there, right? We know what the column names are, etc. Okay, you've got everything you need to know to write those answers. All right. Oh yeah. So these questions, how do these counts compare? I've copied and pasted these questions over here, so we can just read it from here right now because we just have a sequence of exercises. How do these counts compare to that earlier data, Arbuthnot's? Are they of similar magnitude? All right, so how would we know? Well, we can start with the Arbuth data set. We can just look at, both of them have boys and girls in them, so we can do one or the other, it doesn't matter. Let's do girls. And we can print those values. Oops, sorry. And then we can do present. And for the sake of alignment, I'm going to put some spaces in there just so that it's a little easier to read. And I'll print that. Okay, these are very different, right? One is thousands and one is millions. So they're not on the same scale. One thing we could do is we could calculate, say, the median value for each one, just sort of as a basic example. And that sort of gives us what we need instead of printing all the values. So, I would write something like, the Arbuthnot's are in the thousands and the present day number of births are in the millions. You could even, the other way maybe is slightly better because it tells you about the uncertainty or is the range of the data. So the Arbuthnot is roughly from, for girls, for example, is roughly between 3,000 and 8,000, whereas the present day girls is between 1,000 and 2,000, roughly, right? Oh, you know what? I will show you one more cool thing. You can put our code into your prose, into your paragraphs, okay? So let's go over here and look at the output for this question. How do these counts compare? Are they of similar magnitude? So here's the range. You know what? Let's work with the median because that's going to be a single number. Okay, and we know what those numbers are. We just put them down here with Control-Enter. So let's put these values into a sentence. Okay, Arbuthnot's data, the median for girls is, and then we're not going to type the number from here. We're going to have R calculate it and put it in the text. Okay, so I'm going to put 2 single tick marks, just like the code chunks has 3 left tick marks, but here we have 2 single tick marks. The first character after the first tick mark is the letter R. So whatever comes next is going to be interpreted by R, and the output will be printed here. So I'm going to copy this command because that's the command that produces the value. And then it ends with a tick mark. Okay, I'm going to run this, and we'll go look at the output. And this is one of the real powerful parts of doing this. In Arbuthnot's data, the median for girls is 59.18. Isn't that nice? If you haven't seen this before, like that, I hope that's impressive, and you can sort of see how powerful that is. If I go and modify the data, say I remove some observations or I read a new data set in, and I render it, all the new values are automatically put in. I don't need to modify my text. My text modifies it itself. Okay, and then I'll just copy and paste this. In the present day US data, the median for girls is, and the data set was present. Okay. So I can say in the thousands, in the millions. Maybe I'll use words. Thousands. Okay. So we'll render that, and we'll just see the result. I told you this is going to be a long video, lots of details. Okay. Okay. Ah, interesting. Okay. I'll show you what's happening here. In our Arbuthnot data, the median for girls is 5,700 in thousands. In the present day US data, the median for girls is this number, 1.83 times 10 to the positive 6 in the millions. So this is scientific notation. Okay, how do you have it not print scientific notation? That's sort of annoying. There are multiple ways of doing that. Let's not worry about it. Okay. We'll leave that for another time. Okay, we'll continue. All right, the proportion of boys in the U.S. So we've already calculated the proportion of boys for the Arbuthnot data. Let's do the same thing for the present. So I'm going to go up and copy my code, come back down here, proportion of boys. So we need to, what do we need to do here? We need to change the data set. Okay, and then in the present data set, so I've highlighted it and I press Control Enter so it put it down here and printed it. What are the variable names? I think they're the same, right? So we've got boys and girls. That will give us, the sum of that will give us the total, and then boys divided by total will give us the boy ratio. So the same code is going to work exactly. So that's sort of nice. Okay, make a plot that displays the proportion of boys born over time. So I think we did that also, right? Here we've got boy ratio. That was back in question 3. Okay, so we just copy and paste. And then we have to figure out what we need to change. We almost always need to change the data set. Okay, but the other variables, we have year in the data set already, and we have the boy ratio, which is what we're creating. Everything else is just calculated, right? So let's run the first piece of code. I'm going to put my cursor anywhere on this long chain of code, because it's all one command, even though it's multiple lines. It's chained together by the pipe and by an open and close parenthesis and by an assignment. So they're all glued together as a single line. And let's look at what that data looks like. Okay, present. So now we've got our two new columns, and we can print the boy ratio. So now these are individual lines, so I'm going to press Control Enter, one for each line. And that's the data. Let's see, if I go back one, right, that was the data for the Arbuthnot, or whatever that guy's name is, and this is for the US. So now we have actually a slightly decreasing relationship. But, and there's quite a bit of variability here, but look at the y-axis. It's 0.513, and it varies between 0.512 and 0.514. So we're talking about tenths of a percent variability over this time. But there is still a decreasing pattern here. It just is, the amount of decrease is very, very small because we're dealing in the millions. Okay. What's the question here? What do you see? Well, I see a decreasing pattern that decreases only about, on average, about 1 to 2 tenths of a percent over that, from 1940 to over that 60-year period. Does Arbuthnot's observation about boys being born in greater proportion than girls hold up in the U.S.? Well, is this greater than a half? Yes or no? Include the plot in your response. Okay, good. So you can write out some of those conclusions here. All right, I think are at the last part. So what is the year with the maximum births? Okay, in what year did we see the most births in the US? Well, we've got the totals saved already, right? So we've got present. That's the data set. So we're going to do something with present. And then what do? Well, how can we find the maximum for total? There's lots of ways of doing this. I'll show you a few. So we can do total, and we can do max. Okay, so that is the value of total. But we don't know what year it is, right? The question is asking in what year. So we need to know what year this is. So this doesn't quite give us the answer. So what else can we do with our data set? We could sort it. And in the tidyverse, sorting is arrange. So we could arrange the data set, arrange the rows of the data set by total. Okay? So let's run that. And you can see total here is the smallest, and it's increasing throughout, right? That's nice, but we don't see the maximum value because it's down at the last row. So we could change the order. We do that by, we want to arrange by total descending. And actually piping it is, you can pipe it, but you'll more often see it this way. We're going to be descending by the total variable. So let's run that. So now we've got total is the maximum value, and the numbers are getting smaller. So now we can just read off the first row, 1961. All right. Once we've done that, we might want to print out just this year, because we haven't really answered the question with the code. We've been able to pull from this table the result, but we might want to just print out only the year. Okay, so there's lots of ways of doing this. There's a function called slice. If you slice the data set, it's a way of selecting which rows that you want. And we want, in this case, the first row. Okay, so if I run that, it has, from this full table here of 63 rows, it has sliced the first row. We're getting closer. Now we want to extract just the year. So then there's another function called pull, where we're going to pull a certain column from the data set and just report those values. So now we've got an answer, 1961. So this is all over the top, but the purpose in this video is to show you some of the power that you have for manipulating data sets. Yeah, that's pretty good. So let's make sure we've answered all the questions. I believe I have. We come back here, question 7. Okay, they show this arranged descending, so that works just fine. And there's, I do recommend all of these. These cheat sheets are so data visualization, that's going to be ggplot. Data transformation, that's going to be dplyr. And markdown, our markdown is going to be how to manipulate text. I do recommend downloading and viewing these cheat sheets. In fact, if you have a printer and you can print them out and you can have them next to you, let's go ahead and look at one of these. Yeah, I'll just save them into my ADA folder. And we'll go take a look. All right, let's look at R Markdown to begin. Okay, so we're using a a newer version of R Markdown called Quarto, but almost everything in it is the same. This cheat sheet has 2 pages, and it goes through about doing italics and strike through and bold and different headers, itemized and bulleted lists, even like putting in citations and stuff. I'm on the 2nd page now. It's a little bit hard to see the whole thing because they've done something to the document that makes it. Oh, I know why. I need to shorten up my window. Sorry. My screen is bigger than the window that I'm recording in. So, but if I resize the screen to fit. Okay. Anyway, there's a bunch of stuff in here that could be helpful. Let's go over and look at the visualization. All right. Nice. So with visualization, you create a coordinate system with your ggplot. Okay, you've got some, oops, aesthetics and so on. And then if you want to do things like histograms and dot plots or things, these are the functions that do each of those with little icons that show the picture of what you're doing. If you've got 2 variables, you can make scatter plots of points or smooth. We did that one, etc. Okay, if you want to visualize error like confidence intervals or error bars or interquartile ranges, you can put those in there. On the 2nd, there's different ways of calculating certain statistics and visualizing them, or changing the scales. Scales could be like a date scale, or defining limits on your axes, things like that, or log scale, reversing the scale if you want to swap the order, descending versus ascending, different coordinate systems, faceting. I use facets all the time to make grids of plots. Anyway, so lots of good things in a small area right here. Let's take a look at transformation. So this is using dplyr. So you start with a data set. You can summarize in different ways. We did that once with the min and the max of the boy births. You can group by and then apply a function to each group and then combine the results of that. I do that all the time. For example, yeah, I'm not going to do examples at the moment. Let's see, filter. So manipulating cases, this is like having to do with how do you do things with rows. So you can filter which rows you want, pull out some rows and don't use other rows. Distinct is a way of like finding unique rows in case you've got duplicates. Slice we just used to pull the first position out. You can slice, that's what we could have done. We could have done a slice max to select the row with the maximum value. Let's go do that. That's something I don't do very often. So let me do this in a new code chunk. So this is going to be a slice max, and it's going to be the max total. Okay, so we start with the present data set. Okay, that's the full data set. And we're going to slice max. We're going to keep the row where for the maximum value of total. It did it. Look at that. One line of code. And then from there you can pull the year out if you want. Cool. So, boom. Always learning. A good data analyst is always learning. Okay. I'm going to sort of skip a little bit. I'm not going to worry too much about vectorized functions. I don't use those very much. I do use summarize to calculate certain things. N I use all the time to count the number of values. Let's see. Combining tables. binding rows and binding columns. I do that to bind things together. These, if you have relational data, you can join things together by certain columns. Anyway, I'm just saying things now that aren't going to land because I don't have examples. But these are very valuable summaries of using common functions in the tidyverse. So print those out, have them at your desk, and I think you will grow faster with them. All right, thank you for for sticking with me for a long video. I hope you got some value out of it, and the assignment should be done. See you in the next one.